All right, and we're going to be doing the Check Your Understanding for topic 512, exploring the behaviors of implicit relations. Let's go ahead and get started with our Check Your Understanding for 512. So consider the curve in the xy plane given by x squared minus y squared divided by 5 equals 1. It is known that the first derivative is equal to 5x divided by y, and the second derivative is equal to negative 25 divided by y cubed. Okay, find the critical points of this curve and justify our answer. We know critical points occur when the first derivative is equal to 0. So when 5x over y equals 0, which happens when x is 0. Now the question is x ever 0 on this hyperbola? So if I plug in 0, actually, the hyperbola, I'm going to say that x is never 0 on that hyperbola. This is hyperbola that opens up and down, but it doesn't go through the origin. So, which does not occur. Well, when x is 0. Doesn't go through the origin, that's not the point. The y has a value. Okay. Yep, it does. So when x is 0, that means this would be equal to 1. And so this equals 1. I don't know if this opens sideways or up. Hang on. It's opening sideways. I'm going to look at the picture. My brain is not processing well. I know it's hyperbola, I just can't remember what's happening to it. Yep. Y is minusing its second, it's opening sideways. And it's there, it's just not there easily sometimes. Okay, good. Which means x is never 0. Not on original curve. Okay, it's undefined when y is, if the second derivative is undefined when y equals 0. And so y equals 0 and x squared equals 1, so x equals plus and minus 1. So I do have horizontal, the critical points are 1, 0 and negative 1, 0. And those are vertical tangent lines. Okay. Okay, this is justification. Okay. This is not on the original curve. Because if we had solved this, let me just go ahead and solve that. When x is 0, we'd have negative y squared over 5 equals 1, which means negative y squared equals 5, which means y squared equals negative 5 complex numbers. And that's from this part. And so, not on the original curve. I didn't need to graph it. All right, here we go. Is the curve increasing or decreasing in quadrant 4? So in quadrant 4, x is positive and y is negative. So that means their signs are different in quadrant 4. So in quadrant 4, it is decreasing. So dy dx is equal to 5x over y. And in quadrant 4, since the signs are different, x is positive and y is negative, signs are different, that makes this greater than, in quadrant 4, makes this negative. since x and y have different size. Is curve concave up or down in quadrant 4? So in quadrant 4, I'm looking at this curve, the second derivative, and I want to know the sign of it. I don't care what the value is, I want to know the sign. So in quadrant 4, again, x is positive and y is negative. And in quadrant 4, since y is negative, I will end up with negative 25 over y cubed is still my problem. Excuse me. And since y is negative, the denominator will be negative. So that makes dy the second derivative positive. So it's concave up. If this is my equation, different problem, different problem. Okay, different problem. If my curve finds the first derivative, okay, just practice implicit differentiation, have fun. So first times the derivative of the second plus the second times the derivative of the first minus quotient rule down d up down d up minus up d down all over down squared equals 0. So cleaning up, we have x squared dy dx plus 2xy 1 minus, I'm going to distribute, I have y times 1 over y squared, separating, plus x dy dx over y squared equals 0. Okay, gathering, we have x squared dy dx plus x over y squared dy dx equals y divided by y squared is 1 over y, changes to positive, minus 2xy. This is equal to 0. Okay. Then, finishing, factoring out, and we have dy dx equals 1 over y minus 2xy all over x squared plus x over y squared. We can keep simplifying, but we're stuck there. Dy dx is now 1. Okay. Number 3. Multiple choice, which of the following describes the y coordinates of the points on the curve of e to the x equals y, sine of y, where the curve has a vertical tangent line. Okay. So we want to know when the vertical tangent lines will be. Vertical tangent lines will occur when the first derivative is 0. Let's take the derivative really fast. E to the x is e to the x. That derivative of sine is cosine of y dy dx, which means that dy dx is equal to e to the x divided by cosine y. Okay? E to the x is always positive. That means the numerator is always positive. We're trying to find out where it's 0. It's never 0. The numerator is never 0. But I want a vertical tangent line, so I want the denominator to be 0. So the cosine of y is equal to 0. Cosine is equal to 0 at pi halves and 3 pi halves. Okay, straight up and straight down on the unit circle. So, is it 2 pi plus n pi, meaning going halfway around the circle over and over again? 2 pi halves plus 2n pi, which means going all the way around the circle. Oh, for non-negative and negative. Okay. So like these are the same. It's not B and D because we only need to go halfway around the circle to get to the zeros. So we got our circle, and so we only need to be here and here. Okay, that's where we're 0. When y equals pi halves, doesn't matter. Still same. So this question is it non-negative integers or for all integers? And I'm going to say for all, because it can go both ways. Yep, I'm going to say for all. There you go. That's my guess. All right, that's that. Hope you have a great day, and good luck to you, and we'll see you soon. Bye.